Hello everybody, it's old SHAZIZZ here. Not in my original mad science laboratory, but I got some cool video effects. Alright, so let's make a trip around the deal here. Alright, what you're looking at there is my version of my newest plasma reactor. And I want to give you an explanation of it so you can give it a shot, see what you get, what kind of results you get from it. And meantime, let me take this this view off. All right, so basically what I got here is a two-piece glass container that has a separator ring in there that was just to connect it because I had to be able to get the hardware inside of it. These two right here are standard valve stems that you can buy at the hardware store. And I believe this is 1/4-inch copper tubing that goes in, coils up, goes back this way. I got a container on the other side for water, and I got a container on the other side for water. So, if you take a look at this thing, well, let me have to move the camera. You got a coil on that side going to that particular container of water, and you got a coil on the opposite side going to that particular container of water. The power source is a 20,000 volt Beckett oil burner igniter. That is 12 volts to 12 volts at 4.8 amps maximum, and the output is 20,000 volts at 30 milliamps, running off of that battery right there. Let me put you back on the deal here so you ain't all wobbly. Alright, so right now I'm going ahead and giving you a sneak peek of this thing because I'd like to see some folks duplicate it and see what kind of results they get. But essentially what you got right here is a vacuum spark gap that is filled up with argon. And how I did it was essentially I made a an air chuck deal for it to go on the valve stems. And got my regulator so that I'm only putting a small amount of pressure in there, not blowing it apart. But nonetheless, that's how I get the argon in. I got to get me a vacuum pump so that I can vacuum this thing down a little bit. Don't need a massive vacuum, just enough where you get the plasma inside there, that purple glow from the argon. And what's happening here is, even without the argon in there, the arc that's going across there is heating up the coils, which in turn is heating up the water. Once you get the water heated up, you get a thermal siphon going on, so you don't even need a water pump. Basically, the cold water at the bottom circulates and gets drawn in, and then it heats up, and then it spits out that side over there just like a coffee percolator. And so the concept is this: if you get the plasma to surround the coils, you get it vacuumed down real good between the arc and the plasma itself, then that heat will transfer through the coils and heat up the wire. There's two separate containers because this oil burner igniter is going to one side and it's going to the opposite side, and obviously I don't want the water to be even remotely conductive. I want this to act as a spark gap. Now, the problem that I've had with this reactor here is that I needed to get it sealed up just like the other one. I had a failure in the seals. That's been the biggest hard part, and it doesn't necessarily have to be made out of glass, but it's made out of glass because I want to be able to see the reaction that's going on there so that I can explain to people what's going on. And hopefully if I can get this all resolved to where I can get all the parts standard and make them, I might even actually try to put a kit for them together and see if anybody would be interested in buying some kits from me to do research with. But what I believe can be done with this is being able to heat water using high voltage, high frequency, and plasma. And there's a couple other things that could actually be this could actually be utilized for, but I'll talk about that later once I get this thing resolved to the point where it does everything I'm talking about. I talk about this on my radio show all the time, but nonetheless, until I get it done, right now what you're looking at is essentially a water heater. Spark gap water heater, vacuum down, argon filled, and high voltage, high frequency, and the arc itself going across there is what actually charges the thing up. Now, because when I designed this thing, I got a failure. This is made out of wood. You'll see in the pictures I'll post in the video, but this was originally made out of wood because I couldn't get nobody to make me a ring. Didn't have the manufacturing skills to actually make the ring to connect the two glasses together. And it's connected with epoxy resin, and I had to use some glue because it was leaking through the wood itself, and then I had to use some aluminum tape to try to seal this. But the best thing would be that this doesn't even exist at all. It's a glass or a non-conductive ring. That's the only reason why I use wood to begin with, hoping that it'd be non-conductive enough. But since these coils aren't straight up and down, you get the Jacob ladder effect, is what I wanted to have, where the arc would go across the bottom and then work its way up and down the coil system. But what I ended up getting was, just like on the Jacob's ladder, when it gets up to the top, it arcs across over the top, and you actually started burning into the wood, so that's why it's kind of discolored down there. So best case scenario, this thing was all solid to begin with, and you wouldn't have no problems with leaks. The next case scenario would be that you could make this ring out of glass and be able to connect them together and get a perfect seal. These valve stems have a rubber grommet on the back, and there's a two-part epoxy resin underneath the washer that makes the seal on the top. Now I'm going to have to try to spray some soapy water on there to find out. I got a tiny leak somewhere. I don't know where it is, but it doesn't hold its seal very long. But the reason why I want to show this to you early, give you a sneak peek at it, so that if you decide you want to try to replicate this, and you can let me know how yours works out. The oil burner igniter is supposed to be a constant duty oil burner igniter, but I do notice that after it runs for a while it gets hot. And because that kept arcing across the top, which I'll show you here pretty quick, I'm gonna go ahead and connect it. I connected a blinker light switch to it so that it would shut itself on and off, and you can actually see the effect of the Jacob's ladder going up, and every so often you might see when it arcs across to the wood, and you can see it actually burning in there. That's how much heat's going on. And so if this was all done correctly, properly manufactured, you would be able to heat water in the milliamp range using high voltage, high frequency. You see inside, well, I guess you can't see it right now unless I run it for a while. It takes a little while to get it warm. You'll feel this first start to warm up. You'll start to see the water level shooting off into the deal just like a coffee percolator. And after a while, the water temperature rises up inside there. And that's about the best explanation I can give so far, but it uses a thermal siphon to actually circulate the water in there. And there could be a whole lot of different uses for it, like I said earlier. I'm just going to turn this on for a second, and you can get just a general little peek at it. Hopefully it don't mess with the camera. Takes a second for that blinker to start going. And I don't know if the camera's even in the right angle so you can see. Well, I can't tell whether or not it's showing up on camera right now or not. But either way, with my wireless AC tester, you can see it's pulsing outside the reactor there. And let me turn the view just a little bit. on the water hose, that container of water. I hope you're seeing that. It's hard to tell what's showing up on here. But either way, let's leave that down there for a second. You can see as it's pulsing, you can leave that thing on constant. I'm going to turn the light off for a second, see if I can get a better view. Alright, let's try this again. So my guess is that you probably wouldn't want to like stand in the shower with a hot shower with this going, because it's probably pretty charged. But nonetheless, it shows what I've been trying to show a long time about energy transfer. If you can heat water in the milliamp range, I think that's doing pretty good, even though it's 20,000 volts. But I'm starting off with the 12 volt battery that the oil burner igniter uses 4.8 amps maximum, and the output, like I said, is 20,000 volts at 30 milliamps. So it's actually heating water. When you run it long enough, you'll actually see the thermal siphon start. That's why I got these marks on here, so that you can see where the water was, and then you'll be able to see where it is, and you'll actually see it pumping. But you got to run it for a little while. If you go look at my video, Redneck Hot Tub, you'll see that I used a coffee pot element to heat water up, and you could get that entire thing, even though it's open in the atmosphere and not insulated underneath. You can get that water so doggone hot in there after running it for about 4 hours that you can't even sit inside that hot tub. That's how well it works. And so I believe that this same process right here, by transferring the plasma heat to those coils, that you could do the same thing, and I think even better than that. So this is why I want to show you a sneak peek and let you have an opportunity if you want to try to, manufacture that. The flaw that I got, like I said, is that this doggone aluminum tape covered piece of wood, and see, that's coming through the glass and it ain't actually coming through that wood. That's kind of weird. But nonetheless, look up the mercury arc rectifier and you'll understand what else this is capable of, and a few other things that I'll explain to you once I get this thing perfected. So with that said, I hope you enjoy the video. Peace and love, everybody. Take care. Oh yeah, one last thing, a little short addendum here I forgot to mention is that it doesn't have to be a Beckett oil burner igniter. You can use, one of the little flyback transformers or something like that to do the same thing, or even a Slayer exciter circuit, and see how efficient you can actually get it to happen. G. Bluer, I guess he's the one that originally invented the Slayer exciter circuit, but if you need a copy of it, there'll be, you follow the links to my website, there's some in the Mad Science podcast page, the diagrams for that. So, with that said, the Slayer exciter circuit and maybe a little cooling fan on that, I guess, would probably be pretty efficient. Brian Abrams and Terry and them's been doing some pretty cool work with those things. Those will be a couple to check out on it. But anyway, I wanted to add that. Sorry I forgot that. Peace and love, everybody. Take care. Alright, doggone it, did it again. One more short addenda, something I think I forgot to mention. Maybe I did mention, but I just don't remember. Is that eventually, because I'm inside and I'm not in my old lab where I had access to a good earth ground, is that I'm using both sides of this oil burner igniter. And the best case scenario is that you're using one side of the oil burner igniter to one coil, and then on the opposite side, these copper tubes still hot. On the opposite side, this one here would go directly to earth ground. And so that would give you a better arc inside there. And I'm not positive, but I think you'd be running off of 10,000 volts. I think the combined of them is 20,000, but I think 10,000 off one side. I could be wrong. It could be 20,000 volts on both sides, you know, or combined. Either way, even with the Slayer exciter or whatever, I think it would be best if you had the high voltage coming in this side, and or either way, don't matter. But the other one connected to earth ground, and so that way you'd get a better arc inside there. Either way, try it out if you like. Let me know what you come up with, and throw your comments down there if you have any suggestions, or anybody that you know that might be able to manufacture these properly. Peace and love, everybody. Take care.